So, what exactly is machine learning? Let's find out and gain an insight on the basic principles of machine learning. What is it? So, basically, machine learning is a study of various algorithms that depend upon a given data to improve their performance. These algorithms allow the computers to make predictions or take decisions without being explicitly programmed to do so. So these are some of algorithms which are basically designed in such a way that these do not need to be instructed for each and every step or how we want to solve this problem. These algorithms learn on by themselves with the help of a given data to make predictions or whatever task they are used to do. ML algorithms mainly comprises of formulating a mathematical model and apply some optimization techniques to devise an efficient predictive model. So the primary gradient to make these algorithms learn is through some samples of data called the training data. And with the help of this data, the primary task of the algorithms is to create an outcome with the least possible error. So this is the main idea behind machine learning. Let us understand what are the various paradigms of machine learning and how we can define them. So machine learning has three important paradigms. These are the supervised learning, the unsupervised learning, and reinforcement learning. So let us see what is supervised learning. So supervised learning is basically a study of algorithms in which we have the training data in which both the input and output is available. For example, if we want to work with a set of images of cats or dogs and want to predict whether the given image is of a cat or a dog or some other animal, then this falls under the case of supervised learning. Another example can be predicting the market forecast and whether the stock price is going up or down, or some other examples. So again, availability of data divides the supervised learning algorithms into two different classes. One is the classification and other is the regression. So in the case when the data available to us is of finite set of symbols, for example, if you want to predict whether a given image is of a cat or a dog, in this case only some few possible outcomes are possible. So then this task goes in the case of classification. Some of the examples are fraud detection, image classification, as I told earlier, customer retention, diagnostics. Diagnostics can be whether we have profile of people in which we have their BP values, glucose levels, and we want to predict whether the person will have diabetes or not. Then these fall under the case of classification. The second category of supervised learning is regression. So in this case, our output variable consists of values which can adhere to any possible value. For example, if you want to predict the price of a stock of a certain company, so this can take any positive value, right? Another example of regression is weather forecasting, estimating the life expectancy of people of a certain city or a certain area, predicting the population growth, whether it is going to increase or decrease after a certain period of time, and so on. So these are the supervised learning algorithms and their the paradigm of machine learning. The second paradigm of machine learning is the unsupervised learning. So unsupervised learning, unlike the supervised learning algorithms, rely on unlabeled data. Unlabeled data means we have only the set of inputs and no output is available. So this is unsupervised learning. Some of the examples of unsupervised learning is clustering. So what is clustering? So assume that we have a training data of certain objects, and we want to, and through this training data, we want to create groups in which the objects lying in the same group are as similar as possible, and objects lying in the distinct groups are as dissimilar as possible. So examples of clustering are creating a recommender system for movies or targeted marketing and customer segmentation. Second example of unsupervised learning is dimensionality reduction. So dimensionality reduction refers to the cases in which we have a large set of features and we only want to work with the features that are useful, and we want to discard all the features that sort of don't have any value or have very less value than the ones we want to work with. Some examples of dimensionality reduction are compressing the images or text files, big data visualization. For example, if you want to visualize a very big, large data into a meaningful representation, then we use dimensionality reduction. The third important paradigm of machine learning is the reinforcement learning. So in this case, the algorithms create a simulation or a game-like situation in which we learn the correct output with the help of with the help of penalizing the model with if it does a wrong task, and rewarding it if in the case of a good task. So for example, game AI. Uh, Another example can be robot decisions. Uh, Another example is taking real-time decisions with the help of reinforcement learning, acquiring some skills. So reinforcement learning can be analogy of training a dog. For example, when we want to train a dog, and if we want him to bark at certain situations only, then we reward the dog by giving him or her a treat if the dog barks when we want him to it to bark whether at the correct time, and we penalize the dog by not giving him or her treat when the dog barks at the wrong time. So this is an analogy of reinforcement learning in the real life situation. So these three are the most important paradigms of machine learning. There are some other paradigms of machine learning as well. So these are the semi-supervised learning. In this case, we have a very small set of labeled data and very large set of unlabeled data, and then we use this type of data to create a model that creates a predictive model further. Another is self-supervised learning. Third one is the transfer learning. In the transfer learning, we use a pre-trained model and use the knowledge from this pre-trained model to boost the performance of some another task. Fourth is online learning, and the last is meta learning. These are the some most important paradigms of machine learning. So in this video, we summarize the basic and importance of machine learning and its paradigms. So in the next video, we'll talk about the other aspects of machine learning, and stay tuned for the upcoming lectures. Thank you for watching.